Welcome to the ScepticalBrit's first video. Today we're talking about climate change. Oh boy. To understand climate change, we first need to understand what the atmosphere is. Part 1. The atmosphere. An atmosphere is a set of layers of gases surrounding a planet or any sort of celestial body really. Moons, the sun has an atmosphere. If anyone's seen a total eclipse, then the corona is actually part of the sun's atmosphere. The Earth's atmosphere itself consists of around 78% nitrogen, 21% oxygen, around 1% argon, and, well, percentage-wise, very little carbon dioxide. The atmosphere plays an important role in the heat retention from the sun. Part 2. How the atmosphere retains heat. A good example of how an atmosphere helps retain the heat is to look at a body that does not have an atmosphere at all. This is Mercury. Actually quite pretty, really, when you think about it. It is the first planet in the solar system closest to the sun. Because it doesn't have an atmosphere, its temperature range varies drastically. In the daytime, it is a scorching 426 degrees Celsius. During the night, though, it plummets to a Canadian summer of negative 173 degrees Celsius. There is no atmosphere to retain the heat overnight. Because of this, heat can freely radiate from its surface. That all said, though, Mercury isn't the best of examples when it comes to this, as its rotation period is actually longer than its orbital period. Mercury takes 58 Earth days to rotate around itself, while it orbits around the Sun in 27 days. If we want to get a clearer example of this, then it's best to stay close to home here. Earth itself's range is from about negative 88 to 58 degrees Celsius, while the Moon ranges from negative 233 to 123 degrees Celsius. As you can see, even the act of having an atmosphere in the first place reduces the range of minimum and maximum temperatures. The way the atmosphere retains this heat is through gases called greenhouse gases. Part 3. Greenhouse gases. There are 4 major greenhouse gases within the Earth's atmosphere, each varying in potential effectiveness. The 4 are carbon dioxide, water vapour, methane and nitrous oxide. The basic sources of these gases are a mixture of natural and human activities. Carbon dioxide sources are the carbon cycle and energy generation. Water vapour sources is evaporation from oceans and evaporation from soils. Methane sources is from agriculture and energy generation, and nitrous oxide sources are from agriculture and general waste. Part 4. Greenhouse gases. How do they work? If we're going to be pedantic about it, and I'm a YouTube skeptic, and I'm going to be, then the term greenhouse gas is actually a misnomer, because that's not technically how greenhouses are warmed. Greenhouses are mostly warmed by blocking of convection of warm air. Warm air rises, but if the air cannot rise anymore, due to a roof say, then the heat is retained. That's basically how your house rooms are heated. Your radiator heats up the air rises, it cannot move anywhere other than when it hits the ceiling, it moves about and then cools down, but it's still pretty warm, so you get warm. That said, however, some of the warming does take place due to the glass walls acting like the Earth's atmosphere. The sun heats the Earth's surface, the surface then heats up and begins to radiate heat as infrared back into the atmosphere. Greenhouse gases then absorb this second source of infrared and is then re-emitted to be absorbed by the surface again. Greenhouse gases have already absorbed some of the infrared heat from the sun to begin with, so that's why it's a second source of infrared. Part 5. Anthropogenic. The first question that should be asked is, could climate change happen naturally? And the answer is, yeah, pretty much. There are several ways that climate change could happen naturally. One is a wobble in the Earth's orbit. Any sort of way that the Earth's orbit could be affected, maybe through Saturn's gravity, or more than likely Jupiter's orbit, really, as Jupiter does tend to help clear out the solar system when it comes to asteroids and meteors and whatnot. It could affect the Earth's orbit by changing it slightly so it gets closer to the sun. Sometimes thus the amount of heat from the sun is increased slightly. Around the world there are several CO2 and methane sinks, basically just reservoirs full of methane that are either frozen or trapped in rocks or whatnot. Any sort of disruption to that could cause a load of methane or CO2 to come out of those sinks. Say an earthquake disrupting a rock cracks in it and it seeps out, or methane ice thawing. There could even be a large CO2-filled meteorite hitting the Earth. The meteorite itself vaporizing and releasing all of its CO2. As it happens though, we are currently disrupting a major CO2 sink. Fossil fuels in itself are just such a massive source of carbon. Burning these chucks billions of tons of carbon into the atmosphere. Also, cows burp methane, but we'll talk about that in a later video. So what are the effects of climate change and what can we do about it? That's something I'll talk about in the next video. If you enjoyed this video, please give it a like, subscribe, and I'll answer any questions in the comments. Hi everyone, seriously, thanks for watching this first video. As you can probably tell, it's a bit rough around the edges. Apparently 6 like 6-7 months worth of me actually doing YouTube in another capacity has not really helped when it comes to reading off a script. but it would be great if you put some feedback in the comments down below, like I said, and yeah, if you got any questions, then I will attempt to answer them. But yeah, thanks for watching. Bye. Gases, 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 gases.